Let's look at this question. This is a question about polarization, or more specifically, how the intensity of the light changes after passing through a polarizer. So the relevant concept would be Malu's law. If you recall, Malu's law states that I is equals to I naught cosine square theta, where I refers to the intensity of the light after passing through the polarizer, I naught refers to the intensity of the light before passing through polarizer, and theta refers to the angle between the axis of polarization for the polarizer and the orientation of the light. So let's look into the further details of the question. In this question, we can identify two main situations. In the first situation, we have two polarizers A and B. We are first informed by the question that as light passes through the polarizer A, the light intensity is observed to be I. To better understand what is happening here, let's first assume an axis of polarization for A. Let's assume that it is vertical. So as the light passes through A, what we will get after A is light in the vertical orientation with intensity of I. We are then told that this light that passes through A, after it passes through a second polarizer B, it is observed that light that passes through B also has intensity of I. This must mean that the light passing through B must also be in the vertical orientation. That is why it has intensity of I. Based on this, we can conclude that the axis of polarization for B must also be vertical. So now let's come to the second situation. In the second situation, we still have A and B. But now what happens is we add another polarizer C in between A and B. And when this happens, it causes the light that emerges from B to become having intensity of 2/3I. Based on this result, the logical deduction must be that C has an axis of polarization that's different from A or B. Let's assume that C has an axis of polarization that is at an angle of theta to the vertical. Let's now look at what happens to light as it passes through from A to C to B. So as it passes through A, we will still get the same situation as before, that the light is in the vertical direction with intensity of I. Consider what happens to light after it passes through C. So after it passes through C, what happens is we will have light in a direction, in orientation that's parallel to the axis of polarization of C. That is, the light will be at an angle of theta to the vertical. In this case, the intensity of light must have dropped to something that's below I. Let's call this new intensity I prime. Now let's consider the last part about passing through B. So this new light intensity of I prime that passes through B will become vertical after passing through B, and it will have an intensity of 2I/3. So let's consider Malu's law. Let's apply it to the situation to form suitable equations to solve the question. First, let's consider light passing through C. Based on the situation, we'll get this equation that I is equals to I prime is equals to I cosine square theta. So this is our first equation. Now let's consider light passing through C. Through B. So based on the situation, we'll get 2I/3 is equals to I prime cosine square theta. And this is our second equation. So combining these two equations, we will get 2I/3 is equals to I cosine square theta times cosine square theta. And from this, we get cosine to the power of 4 theta is equals to 2/3. So by solving, realize that theta is equals to 25.4 degrees. And therefore, the answer is option A.